And on today's video, we'll be checking out the atom and its parts. An atom is nothing more than the smallest particle of any single element that we have. Okay? If you think we have carbon, hydrogen, nitrogen, oxygen, take the smallest piece, the smallest little particle of that element, and that is what's known as an atom. And it's said to be the smallest particle because it actually still retains the characteristics. It still retains the properties, the smells, the appearance, the looks of that element. Now over here, this is a really just general picture of an atom looks like. It looks nothing like this. This thing has been exploded in size, so you can actually get an understanding of what its inner parts and the inner workings are like, but it does not look like this. In fact, this is stuck in place, and a real atom moves around very, very rapidly. It vibrates. The electrons are moving very quickly too. So just understand that this picture is only for a learning, understanding of what the parts are. The nucleus of the atom, which is right in here, the nucleus of the atom contains the positive protons and the neutral or zero charge neutrons. And we're going to have the electron cloud on the outside. The electron cloud is the zone that surrounds the nucleus. And this is a zone where we say electrons are found 90% of the time. Okay? So electrons move outside the nucleus in orbitals, not in circular orbits, but what's known as orbitals. We use the word subatomic to describe parts of the atom that are smaller, or subatomic particles smaller than the atom. The three subatomic particles we'll be discussing today are the protons, the neutrons, and the electrons. The first particle we'll look at is the proton. The proton has this little P plus sign next to it. That's P with a superscript next to it for positive. And sometimes it's written as P, with a 1 plus next to it for the one positive charge. It has a really, really small mass. The small mass, if you look at the exponent here, is 10 to the negative 24th. Just to give you a little bit of understanding, that's a 0 with somewhere around that many zeros and a 1675 grams. Now, that is crazy, crazy small. That's why we need scientific notation to describe it. But even still, this is ludicrous small. And how is any scientist really going to discuss that with another colleague? They have invented a way, and that is they term it a relative mass. And the relative mass of a proton is known as 1 AMU, and it stands for atomic mass unit. So a proton has 1 atomic mass unit as its relative weight. So we really are not frequently going to reference this crazy small weight. But anyway, they're found in the nucleus along with the neutrons. A neutron has a 0 charge, and that's what I put right here. That's the charge 0. So it's an N with a 0 next to it. As you see, it's literally the same size as a proton. And in fact, if I went out a few more decimal places, I'd find it's a tiny, tiny, tiny bit bigger than the proton. You're also going to see its relative mass is 1 atomic mass unit. And that means compared to the proton, they have the same exact mass, relatively speaking. Now that's in direct contrast to electron. The electron is going to have so many more zeros. It's going to have 4 more zeros on it, meaning it's a lot smaller. It's a lot smaller in mass than the proton or the neutron. And how small? 1/2000 smaller. And these guys are going around the nucleus in orbitals, not in these circular orbits as this picture shows. That's not true. But what's known as orbitals. And they're moving at crazy high speeds. Once again, difficult for us to imagine because we're talking about something that's so small and moving so fast.